All right. Good evening, everyone. I'm Mark Gross, and I'm the founder of the School of Ranch. If you haven't heard of us, it's because we're brand new. And fortunately, in our young life, we've been able to make contact and work with such wonderful colleagues as Pam Wavering of the Roundhouse Foundation and Andy Smith of High Desert Food and Farm Alliance to put on programming like what you're going to experience tonight around biochar. It's been a fantastic experience, and really, most of the credit for tonight goes to Pam Wavering, whose foundation sponsored this, is providing the farm, got Kelpie to show up, everything else, and then to Andy, who organized and ran the project and acquired all the muffins for next Saturday. My only task was to do the registration form, which I managed to screw up, so I'm not sure I'm going to be invited back. So anyway, I want to introduce Kelpie Wilson. Who would have thought a few years ago there'd be the term biochar superstar? Well, I think we're all really lucky that exists. It's good for the world, and it's good for the United States, and it's great for Oregon, and we're really lucky to have Kelpie with us. I'm going to look at her little bio here. Kelpie's an engineer and an analyst with 35 years experience in sustainable energy, forestry, renewable energy, sustainable forestry, and resource conservation. She was a founding board member of the US Biochar Initiative. Her list of clients includes some of the most prestigious organizations around: the Washington Department of Ecology, the Forest Service, and it goes on and on and on. It's fantastic. She continues. She's been doing this since 2008, right? I mean, who was involved with this in 2008? So she really has a tremendous amount of experience. We're really looking forward, Kelpie, to learning from you tonight and then working with you in the field next Saturday. And without further ado, I'm going to turn this over to you.
All right. Thank you, Mark.
Sure.
And thanks, everybody, for having me here. I'm really happy to be here. And just want to say I'm from Cave Junction, which is in the southwest corner of the state. And Pam, the Watershed Council just told me about a gift from the Roundhouse Foundation that paid my friend Sarah for some art that she contributed to their Coffee with Quail event. So that's just a nice connection there. We can all help each other out across the state and across the world. Actually, I talk with people all over the world about biochar, and it is really fun. I'm going to share my screen, and I've got a lot of slides to show you. Hopefully it will do a good job of illustrating what we're talking about. All right, I've got two parts to this. One is just what is biochar? How do you use it? And then more in depth on how to make it. These pictures are from a youth camp that we do every year that is an on-ramp camp to forestry careers. And we have a lot of fun on our biochar day always. And come on, okay. So you've already heard about me. I do have a background in forest conservation as well, so that's a big focus of mine is forests. But what is biochar anyway? This weird name for this weird stuff? Well, you know what? It's just charcoal. It turns out, though, that charcoal can have a lot of different properties depending on what it's made from and how hot you cook it. And some of it's good to put in soil, and some of it you wouldn't want to put in soil. So my definition is it's charcoal that's suitable for soil. And what does it do when you put it in soil? Well, it adds carbon. We know that's important, soil carbon. And it helps conserve water. It prevents nutrient loss. It buffers soil pH, promotes microbes, and increases plant growth. In some cases, it really is very obvious what it's doing, like a degraded soil or a contaminated soil, like these pictures are from. In other cases, you might not notice right away a huge difference, but over time, it lends a lot of resilience to soil. So how do we know this? How do we really know it works? Because it's such a new thing. Well, it's actually not such a new thing. There's a lot of charcoal naturally in soils. In fact, the most fertile soils in the world, and that would be the ones in Iowa, have a lot of charcoal. So half the carbon in these soils is charcoal. And where did that come from? It came from prairie fires. So they left behind charcoal. And that was even enhanced by Native American burning practices, very similar to what we see in our forests here as well. that there's charcoal in them. And then some cultures really got into it. So, you know, you probably have heard about the terra preta, which is Portuguese for dark earth soils in the Amazon, where, you know, for decades, people, or, you know, modern scientists thought there could never have been any agriculture in the Amazon because the soils are so poor. Once you clear away the vegetation, the living vegetation, it's just this red soil. All the carbon and nutrients are in the living vegetation. So to grow a crop was just pretty impossible. But then they started discovering these places where there's this rich, deep black soil that could grow crops. And I got to visit one of these sites in 2010 with the International Biochar Initiative. And, you know, so we all got to go down and take our picture in the Terra Preta pit. And one thing that reason they know these are human created is, see all these little kind of holes in here? They all had pottery shards in them. So it was, you know, part of the process of making it was included pottery. And this is where I was, just here outside of Manaus. And it was the land there where the terra preta is 8 times more valuable than the other farmland. Grow amazing crops. And everywhere on the ground, this was a pottery shard that I picked up. They're everywhere on the ground. So, you know, it's really amazing to realize there are more people living in the Amazon before Columbus than there are today. And they lived on these high river bluffs above the rivers, high bluffs. And that's where they created the terra preta soils. But they're not the only ones to do this. They probably did it more deliberately because their soils really needed it. But it just kind of happened a lot. You know, we know about Chinese agriculture and returning the night soil to the fields. And that's what kept that sustainable for so many thousands and thousands of years. But even in European cities, the humanure was trucked back to the farms, you know, until the flush toilet came along, that's what this is a primitive flush toilet. And but, you know, when they were trucking it in buckets and barrels, they used ashes and charcoal from their wood stoves to help control the odor. So there was naturally always some charcoal going back with the humanure. Till the flush toilet came down, we started flushing all our nutrients into the sea, which was really brilliant of us. So how does this work? What's the science behind why the biochar is so effective in soils? Well, to understand it, you need to look at scale. And so you've got our macro scale, the human scale, you've got the micro scale, which is the scale of a bacteria. And then you've got the nano scale, which is the scale of atoms and molecules. So looking at the micro scale or the cellular scale, the bacteria scale, you see that wood has this cellular structure, you know, the cell walls that are strong. And when you heat that up, it turns to charcoal, but it retains its structure, especially something like wood. And so you have all these pores in there, which is, you know, really contributes to how biochar works. And then at the nanoscale, scale of molecules, what's happening is, so you've got lignin, which is the strong part of a tree. You know, you've got cellulose and lignin. Lignin is the strong part that helps it stand up. And it's got a lot of these 6-sided carbon rings. That's called aromatic carbon. And those are called benzene rings. You might remember that from high school chemistry. But what happens when you add heat, see what's attached to all these carbon rings is oxygen and hydrogen. When you add heat, the oxygen and hydrogen go away and the carbon rings link up and make these sheets. So they fuse and condense. So it's called fused carbon rings. And those fused carbon rings are really tough. You know how tough a diamond is. Well, it's not as tough as a diamond, but when carbon links up like that in this configuration, it's hard for bacteria to get their teeth into it, I guess. So this chart just shows the difference between, say, you know, a wood chip that is just, you know, tossed on the ground to degrade versus one that is turned to charcoal first. So what happens is, in the process of turning it to charcoal, which is called pyrolysis, you lose half the carbon immediately, goes into the atmosphere as CO2. That's just unavoidable. But the rest of that, the other 50%, a little bit's going to degrade right away, but the rest of it's just going to stay stable for thousands of years. So that's how biochar can sequester carbon, because the tree grew and built its tissues out of carbon dioxide from the air. And when you char it and stabilize that carbon, put it in the soil, it doesn't go back to the air. So it becomes kind of a pump that pumps carbon from the atmosphere into the soil. Now, meanwhile, your uncharred organic matter, it degrades, the carbon is lost a little more slowly, but it's over a much shorter time period. So initially it's a little slower, but within a couple years, it's all degraded. It's been eaten by microbes. Their respiration puts CO2, all the CO2 back in the air. So that's the difference between charred and uncharred organic matter. So we know it's stable. What else about those carbon rings is interesting? Well, it's electric. It's the electrons. So these are orbitals with electrons. And because they're in this configuration, the electrons can actually move all the way around the ring. And that just gives it some really interesting electrical properties that that make biochar do what it does. So you've got these carbon rings, they're fused together, and they're also in these sheets that are kind of jumbled up called turbostratic. So kind of like potato chips. And so that creates another kind of porosity. So you've got the porosity from the structure of the plant, and then at the micro scale, and then at the nanoscale, you've got the porosity of all this jumbled up carbon sheets. So that's what you see inside here. Now, if you look at that surface in there, what's going on in there is that it's electrically charged. And what likes that is microbes. So microbes like those electrons. They actually use electrons in their chemical reactions for their metabolic processes as they process food. And so on these surfaces, you got electrons. So we like to say biochar is a luxury condo for microbes. Everything's included, electric, water, and food. So there's the electricity, and it helps promote biological diversity at the microbe scale, because it allows more different species to live together. And so they can exchange electrons, because sometimes they need one, sometimes they need to give one up. They're on this electrically conductive surface. So their metabolic processes are very efficient. And we see this in composting with biochar, because it's really efficient. And so there's fewer greenhouse gas emissions because of that. So that's the electric. And, this was one of the revelations for me when I started learning about biochar, is they were all electric. And some microbes even, that's all they need is electrons. So that's very, very interesting. So that's the electric. And then you've got the water. So those pores hold water both in there as a sponge in the pores, and also by electrostatically. So, this diagram kind of shows how if you have sand, the water just goes right through. If you have biochar, and different kinds of biochar might be more electrically active than others, they're going to hang on to that water in the soil, in the root zone of plants. And so there's, different mechanisms by which biochar can hold water in soil. And that's pretty valuable to us. And then the last thing is food. So you've got these electrically charged surfaces. They have cation exchange capacity that holds your ammonium, calcium, and magnesium. And then as things start living in there, the microbes start living in there, they deposit organic compounds that are acidic. And then things like humic acid and other organic functional groups, they're called. And those things now develop anion exchange capacity. So you can now hold on to the phosphates, nitrates, and sulfates. So this char is holding on to all these nutrients, including different metals and clay, that the soil web really needs to thrive. And here's some pictures from a paper that illustrate this very dramatically. They composted biochar with other organic material, got the microbes living in there. And then they did various procedures where they could look at the coating left behind on those biochar surfaces. And there's a lot of it, and it's full of nutrients, nitrogen, phosphorus, and all of that. So, you could call that micro poop and it really helps. So a few years ago, I was involved in a conservation innovation grant, one of those NRCS grants, working with small farmers in Oregon. And we got to do a lot of experiments with biochar. And one of the experiments we did was we made this compost pile. And that's goat manure and straw. And you can see the charcoal layered in there, got nice and hot. We see this a lot, that biochar really helps your compost. I mean, really helps it. It finishes faster, heats up faster, and it's got a lot more nutrient in it. And I'm going to show you our experiment, how we proved this. So we developed this protocol to test our different composts that we made. And what we did was we take just a plain peat potting soil and take, what I did for this one was I took just the charcoal chunk. After it was composted, I pulled some of these charcoal chunks out and ground them up into a powder. And then, but about a tablespoon of that in each of these pots here. So these pots here. And then you just grow them for 2 weeks in a greenhouse and see what happens. And so this one here, the composted char, it had great germination. It had way more secondary leaves and more biomass than any of the other treatments. So this is the control here on the right, the plain peat potting soil. This was some worm castings, which should do pretty well and did well, but couldn't beat the composted char. No compost, just the char. So that to me was a great illustration. Here's one of the other farms we worked with. This is a grass-fed beef operation. And the farmer here has a big pile of high carbon ash that he got from a sawmill where they, burn a lot of waste wood and left behind this ash that's 50% biochar, basically. So we had this stuff. And so the experiment we did here was we put it in the barn because he feeds the cattle in a barn in the winter to, because the fields are really wet. So there's a period in the really wet part of the winter where they're fed in a barn. And you can see that they're trampling the biochar in there and mixing it very nicely. And then at the end, he just spreads it in, it's manure with biochar in it. And he's just spreading it like he normally was. So it's pretty easy for a farmer to adopt a practice like this, when all he really had to do that was different was, put a few cubic yards of this biomass ash in the barn at the beginning of the winter, and the cattle did the rest of the work. And here's the result. So, adding that charcoal to the manure led to about 8 times the amount of nitrate or 10 times. So here's no biochar. Here's biochar added in the barn. We did another year where it was mixed in after the clean out. So you see you want to add, and it was better than no biochar, but it's much better to mix the charcoal in at the very beginning of the composting process, not do it at the end. You want to put it right at the beginning. And all that nitrogen that he would have had to purchase otherwise. There's another project we did with a goat dairy outside of Ashland, Willowit Ranch. And in this case, this is a pack barn, and they just simply added 2 buckets of biochar once a week, and also added this stuff called EM1, which some of you might know about. And it was really successful. Here's what they said about it. That first of all, the odor, you're milking goats. You don't want to be overwhelmed with ammonia smell. It's not good for the animals. It's not good for you. And, when you do clean out the barn, once you dig into it, it's overwhelming. You have to wear a respirator. Well, what they found is it composts in place. So it's really, really nice compost. And the animals are healthier, and it's all really good. And they got a little tired of making biochar. It's a fair amount of work. So they started buying it. And that's what I've been saying here. It cost $6.25 a week to eliminate the ammonia and have this better compost. So well worth it, for them. All right, just, while we're on the cow, while we're on the livestock topic, I just want to mention putting it in feed. So there are not a lot of studies, but there are some that show that it does help with methane emissions from cattle to feed them, but it also really helps with mortalities and just animal health and weight gain. So here's something, again, this charcoal is something that, people knew about 100 years ago that we have forgotten about. So, there's some really interesting stuff. If you go on Google Books, you can find old agricultural journals and you can search them and you can look up charcoal and you can find all kinds of really interesting information about what people were doing with charcoal, and feeding it to these prize-winning dairy cows was something that was done. So we need to bring some of this back. And just to complete the cycle here, here's a paper that showed how if you had carcasses, which are hard to dispose of, they added charcoal to the mound where they were disposing of the carcasses in a feedlot, and had really good results with that. All right, so you've got the biochar. Maybe you don't have livestock. Well, how are you going to charge it up? You need to charge it up usually because just putting the straight old charcoal in the soil, it'll start hanging on to the nutrients in your soil. And if you don't have enough nutrients in your soil, if you don't add enough extra fertilizer, the first year you add biochar to soil, you can actually see not such good results. So it's important to kind of charge it up first, and then you'll see really good results. So just weathering it outside in the air and the rain helps start the process. Of course, if you've got animals, that is the best way. Or just add it to your regular garden compost if you're a gardener. That's what I do. Just throw it in there with my grass clippings and weeds and food waste. You can ferment it with bokashi, which is another thing that I do. And if you want to know more about that, maybe we'll have some time for questions. You can soak it in a liquid fertilizer. Some people also just will add it with a chemical fertilizer. That works too. And also, if you can also just add small amounts over time, so it has time to condition in the soil without causing any nutrient tie up. So here's another issue that you want to think about when you're applying soil, especially in your area, because I'm imagining you've got fairly alkaline soils, at least in some of your ground there. And biochar is alkaline, especially the biochar that we make in open flame processes, which I'm going to tell you about in a minute. It's great for acid soils, acid forest soils, perfect. If your soils are already a little pH alkaline, then you probably want to do something to neutralize it. And really, all you need to do is compost it. If you compost it with manure, you're done, because the organic acids from the bacteria are going to neutralize it. But you can also, if you're applying a lot of urea, ammonium that are, creating acidic conditions, it can be balancing to that. You can ferment it with the EM1 bokashi, that's what it is. It's a lactobacillus or a silage inoculant, or you can add sulfur, citric acid, things like that. How do you apply it? Well, you can just add it, till it in the soil if you're doing a legume cover crop. You can add it as you would add compost, or as I showed you with the manure spreader. You can, if you've got garden beds, just sprinkle it on the surface and kind of scratch it in if you're trying to do no-till garden beds. You can add it to planting holes or band it in seed rows under seed. And some people are using a liquid biochar where they take a powder and suspend it with nutrients and use it as a foliar spray. So I haven't done that myself, but I know people who have. So it mentioned legumes. This is a great way if you don't, if you've got a lot of biochar and you don't have time to charge it, you just want to get it in the ground, plant it with a legume crop because the legumes are nitrogen fixers. So you won't get any nitrogen tie up. And you'll also notice, and I've seen this a lot when I pulled out a pea plant or a bean plant from my garden, the rhizobia, those little pink nodules are thick. The biochar really promotes those nitrogen fixing bacteria. And here's some pictures of my garden, just, because I like to brag. And I don't have before and after pictures because I just, it's not an experiment. It's my garden. I'm growing food, and I grew a sweet corn for the first time last year. It turned out great. Someone's in the waiting room. Okay, and here's some onions. And we decided to pile up all of our stuff that we canned in one year and take a picture of it. One thing I've noticed is since I've been adding biochar to my soil, my potatoes are really nice. They're not scabby. They're just really, really nice. And my garlic is fantastic, I have to say. All right. So now we're on to part 2. And we could take some questions at this point. Would we like to do that? If anybody has a burning question, you could throw it in the chat. Or maybe I'll just continue on. All right, so this is part 2, how to make biochar. And sorry about that. So making biochar is pretty simple. The term for it is called pyrolysis, from pyro, fire, and lysis, meaning separation. And if you, okay, is biochar added to commercially produced feed? Not that I know of. Actually, it definitely is not in the United States because it's not legal. There are some veterinary uses that are approved, but adding biochar to animal feed is actually not approved by the FDA. So, but that doesn't mean you can't do it. A lot of people are doing it, making their own. And another question, I've used activated charcoal to help goats that got into some poisonous plants. Any experience using biochar in this similar way? Yes, actually, the biochar that we make and the flame cap kilns, which I'm about to show you, is very similar to activated carbon. So if I look at like a lab analysis of some of the charcoals I've made, they have 300 grams per square meter of surface area, which is like a football field of surface area in a teaspoon of charcoal, which is really something to wrap your head around. But that's all those little tiny pores, all have surface area, all wrapped up in there. So that means it's really powerful for hanging on to stuff. And so that's like, it works a lot like activated charcoal, because activated charcoal starts, you can get really high surface area, but most garden variety activated charcoal is about 500 grams per square meter. And this stuff's 300 grams per square meter, or 300 square meters per gram versus 500 square meters per gram. So it is very much like activated charcoal, which is considered a universal antidote to most kinds of poison. So that totally makes sense to me. Like to understand more about the difference between regular charcoal and biochar. I think we'll be answering that as we go through this next part here. So how to make biochar. We're going to separate the hydrogen and the hydrogen carbohydrate kind of compounds, oxygen in your fuel, wood in this case. You're going to separate that from the carbon. So you end up with 2 products. You end up with gassy stuff, and you end up with carbon, char. So that's what we're doing, the separation. And this is how not to make biochar. So this is how you make fuel charcoal. So fuel charcoal is usually made in a cooler. It's hot, but there's no visible flame. It's made in a cooler smoldering process, and it takes days. So there's different ways of piling up the wood, lighting a little fire in one part of it and letting it slowly smolder through the material. And it's going to be made at about 200 to 300 degrees Celsius. I'm looking at my conversion chart, 400 to 600 degrees Fahrenheit. So it's low temperature compared to what we're doing, which is really more about 1200 to 1500 degrees Fahrenheit. So what we're making is more like a very light activated charcoal, whereas this fuel charcoal it's done slowly because a lot of the tars and oils that come out of it recondense in the pores of the charcoal. So it's great for fuel, but it's not something you want to add to soil, or at least not without a little bit more processing. So that's the difference between charcoal and the kind of biochar that we make. Okay, there's another question, but I'm going to hold the questions till the end now. All right, so how can we make biochar? You know, a good high temperature char. And there's of course lots of ways to do this industrially. There's retort systems, there are gasifier systems that actually collect the gas, and you can run car engines with it, and you can produce the energy. So that's the main value of the industrial biochar, is you can recover energy from it, and that's pretty important. One of the easiest ways, and probably the way most commercial biochar is made now, is just in a standard biomass boiler. And these work, you feed in the ground up wood, and then there's an induction fan that pulls the exhaust out of the furnace. There's tubes here that heat up hot water so you can make steam to make electricity. And then, these ground up wood particles, they catch on fire, but always they're transported out usually before they all burn all the way. So they're little cinders, and they're about half ash and about half carbon. And so what's happened is, here you see how the cyclone filter drops the ash out. A lot of times that ash is very black. So there are a number of operating biomass power plants existing today. And here's one in Medford that's probably the biggest biochar producer in the country. So they're making energy and they're making biochar. And all they do really is they collect that black ash and they filter it. So they screen out the mineral ash. So it's a really pure charcoal. And it's a very high quality charcoal that you get the biochar and you get the energy. So that's great. But we have another problem here that this has been my focus for the last many years, which is our fuels problem in the forests. I'm sure you all experienced the Labor Day fires in 2020 like I did. And so we've got a lot of fuels reduction and vegetation management projects all through the woods that is really important that we do. And a lot of these projects are taking place very remotely, and that material is just never going to get all the way to a biomass power plant. So it's really important that we do what we can do to improve the health of our forests, because these are about the only way we're actually taking carbon out of the atmosphere right now, is through vegetation growth. And we can't really afford to let these forests decline the way they're declining. They need fire, actually, but they need low intensity fire. And in order to return that fire to the soils, to the forests, we've got to remove a lot of the dense vegetation that's there now. And what are we going to do with that? Well, right now we're burning it to ash, but we could be making biochar out of it. So, and returning biochar to the soil that it really needs. So, just like I showed you with the Iowa soils that have natural charcoal in them from prairie fires, same thing with our forest soils here in the Northwest, is they have a lot of natural biochar in them. Up to 50% of the carbon in these soils is charcoal. And, excluding the fire has created these problems. making biochar is what you could even call it a form of biomimicry, because we're restoring these important soil components and increasing our resiliency. These are just some things I found growing in char from char piles that we made in the forest. So, and this is what we see here in my part of the woods. A lot of these little piles after a thinning operation, and they're built to burn hot and complete in their own footprint. And what's left behind though is a scar. So that's just mineral soil there. All the life's been killed. And these can create erosion problems. The process of burning is smoky and so forth. So this has really been my focus for the last few years, is trying to figure out a better use for these piles. And so we've developed, working with a lot of people, developed this this technique of flame carbonization. So it's a form of pyrolysis, but instead of doing it in an industrial plant where there's a lot of controls and and it's very expensive, we're doing it out in the woods in a burn pile or with a simple kiln. And the reason we can do this is because wood burns in stages. So the first stage, when you add heat to a biomass particle, is drying. The water vapor comes off. So, in this picture here, this is mostly steam coming off this pile. Then once the water vapor is gone, you get a flame, because now the volatiles are leaving. So these are the hydrogen containing gases. And that's what makes a flame. If you don't have a flame, you get smoke. And so a flame is burning gas and smoke is condensed gas that didn't get a chance to burn. So then you're left with charcoal or glowing coals. You've all seen this in a campfire at the end of the night, these glowing coals, or maybe in your wood stove. And that's the charcoal. And so in order to save that charcoal and keep it from turning to ash, all you have to do is put it out with water or put it in a can and snuff it. Lots of ways to put it out, but it's a much slower process, the charcoal burning. It burns differently. There's no flame, there's no gas. It's just the carbon burning. So we have this opportunity to save that charcoal. And this picture here just kind of shows how the way we're doing this is we're burning away the outside of the log, which slowly chars. We have to keep burning it till we get the heat in the center and char it all the way through. So we burnt away the outer portion to provide the heat to char the inner portion. And that is the whole secret to how we do this. So somebody's asking about mobile biochar plants. And this is what we've got, folks. We've got conservation burns, which is just a regular hand pile that we put out with water. We've got the ring of fire kiln, which I'm going to demonstrate to you in a couple weeks, or yeah, about a week. Then we've got another style of kiln, which is it's a bin kiln. It's a little bit bigger, but operates on really the same principle as the ring of fire kiln. And then we have these air curtain burners, which are pretty cool. They've got a blower, so you can really control the emissions. And this one that the Forest Service is developing has a char removal system. So that's what we've got for mobile technology. And so I'm going to go through the first two in more detail. So the conservation burn, how we do this. It's a standard burn pile. We light it on top because we want to have that flame there at all times to burn the smoke. And having the flame always and avoiding smoldering combustion not only keeps it cleaner, keeps it hotter. So the thing goes faster. And so we just light them, put them out with water at the end. And here I am, came back a year later to look at one of these char piles in the forest, and that's what I found growing there. That's just an illustration of the difference between lighting it on the bottom of the pile, which people do because it makes sense, because if you want to light something on fire, you know that heat rises, but it's actually hot air that rises. And if you can actually light the fire on the very top, the heat transfers down by radiation. So you don't really have to light things on the very bottom. You can light them closer to the top, and they'll catch fire just as fast, actually faster, because you get more heat. So here's a diagram that shows how the airflows work in this. So you've got your pile, you've got the flame on top, you've got the embers being generated, and then the charcoal underneath. And so, you know, at the right stage, you put that out and you save the charcoal. There's some different piles that we've tried here. When you have bigger logs, sometimes it makes sense to make kind of an open rick like that. And here was a day where we tried some other different styles like this kind of teepee shape. And that worked nicely. The bigger logs kind of held the heat in. And it doesn't look like much, but there's actually a lot of charcoal there. You don't end up burning everything down, you don't end up everything getting charred, some of the bigger pieces, but really when you're in the woods, that's not a problem. Those bigger pieces are not a fire danger and they're good for the landscape. You know, you can actually even use them for erosion control. You can build swales with them. There's lots of things you can do with those half charred logs. And just to show you what it looks like under one of these burn piles that we put out with water, the soil's fine. There's uncharred needles underneath. Here's another burn pile that didn't get put out with water. And yes, it made some little chunks of char, made a lot of ash, and it destroyed a lot of soil too. Oh, just showing you what comes up after the char. And this is what you need. It's pretty simple. If you're burning piles already, all you really need, and is some water. And if you've got a 20-acre big project somewhere, where you've got a forestry crew out there doing all the cutting and piling, and then they come back and burn it, they just need to bring back a water tender. They can be way off the road, because a 1-inch line can go half mile off the road without a lot of trouble. Okay, method number 2, the flame cap kiln. And this is basically a burn pile in a bin. And here's where the idea came from Japan. Early on, when I started getting involved with biochar, we were learning a lot from Japanese researchers, because they were really the first ones to write about it. And some of them sent us these pictures of projects in Japan where they're making all this charcoal. And so I wanted one of these kilns, but I couldn't get one. You couldn't really order one from Japan and have it delivered. So I started making them. But this is how it works. So it's just like the burn pile, but because you have the pan in there, it does a better job of preserving the char until you can put it out. So you can make a lot more char when you have a kiln. And again, the heat radiates from the flame, so you keep the flame on top, and the flame starts to pull the air down. So that's another interesting feature of these kilns, counterflow combustion. So this was the kiln that I started with. I couldn't make that cone. I did make a cone, but it was expensive to make. It's much more efficient to make these pyramid-shaped kilns, and they worked really well. And you can see how in a burn pile, you might get shooting flames from the air transport coming from the sides and shooting up. Here, all the air is coming from the top. So the flames tend to stay low, which helps keep it safer. You don't get flying embers, and you get these really interesting flame shapes. Here's another really good illustration of the counterflow. So you get these curly flame tips. And here's the ring of fire kiln. So we added a heat shield here, and we made the whole thing taller. So the fire's a little bit more down in, and it's more efficient with the heat shield. You can see here that the smoke is rising up and burning. So that's what we want to see. This diagram shows how that works. Airflows are coming in the annular gap between the heat shield and the kiln. And so it's preheating the air, which improves the combustion efficiency. And so you've got air coming from the sides and from the center. So we often see these kind of double flames in that kiln. And here you can see this stick that's kind of sticking out of the hot zone, and how the kiln tends to suck the smoke back in and burn it. It's another picture. We're burning green manzanita here, and it's working really just fine. So here are the steps for processing using the Ring of Fire kiln. You're going to load it up initially, and you're going to load it pretty full, but kind of loosely, because the air needs to come all the way down here. Then you light it on the top, and during the process, several hours, you're going to continue to load it. As the stuff burns down, you just add more and add more. And at the end, you open the kiln up. It's just these panels that bolt together, and you spray it with water and rake it out. It's really important to use dry wood if possible, because you get much more efficiency, much less smoke, better biochar. That's a moisture meter, a really essential tool to have if you're doing this. And then you put the kiln together, you bolt it together, you build a berm around the bottom, because you don't want any air coming from the bottom. You'll get more ash if you do that. You'll load it up loosely with, small dry stuff. Light it on top. And then, let that first charge burn down. So it kind of looks like this, where you go, fair amount of ash, still a little flame, but it's mostly burned down. And so you got the fire went all the way to the bottom of the kiln. And this is when you'll start adding more. And you want to add it at such a rate so that the flame is always maintained, because that's your heat source. So you get the hang of it, how fast to add the material. It's going to depend on, how dry it is, how big it is, what species, things like that. Here's an example of where you want to back off for a minute, because if you keep adding too much, you're going to get smoke. And so this is great, but wait for the flame to come back before you load more. And this is my little mascot here that reminds us to always keep that strong flame on top, because it's your heat source. And here's, it's going pretty good here. All right, and when you get to the point where you're about 2/3 full, by that time you've been working about 4 or 5 hours, usually you're ready to be done. Maybe you've even used up all your material, or you're just tired. So it's time to put it out. And this is again, you want to wait till you see some ash, most of the flame is gone. There'll always be a few pieces on top that don't burn all the way, but that's all right. Time to put it out. So you just open it up, spray it with water, rake it out, and you've got your char. And after a while, you can really appreciate how pretty this stuff is. It's not just ugly black stuff. All right, so, doing these projects, we want to know what we've done for a lot of reasons, including carbon removal credits. And, the first Ring of Fire kiln I made that you guys have one of these is 6 foot in diameter. And that just happens to work out that 1 foot height of biochar in that cylinder is equal to a cubic yard. And so if we assume a cubic yard weighs 200 pounds, then 10 cubic yards of biochar weigh 2,000 pounds, which is 1 ton. And we have a rule of thumb that we use that it's about 1 ton of carbon char is equal to about 2.5 tons of sequestered CO2. So at the end of the day, you can say, hey, I sequestered a ton of CO2 or half a ton or something like that. And we've got some big projects now that have been starting to use kilns. This is the Redwood Forest Foundation. They had their California Conservation Corps crew do some biochar, it was last year, not this year. And they were able to kind of make an estimate for how much CO2 they sequestered, and it's a pretty significant amount. Another project here in Montana. This was a really valuable project because it was done by some real professionals. They were able to estimate the cost per acre. So you can see that it was a little expensive because it's labor. But if you compare it to the cost of buying biochar, you could buy biochar cheaper than that. But in this project, not only did you get biochar on site, delivered, but you also got the fuels work done and you sequestered CO2. So I'm about done here, but the last thing I want to tell you about is working with a group now in South Africa that's developing a carbon removal methodology. So biochar is kind of popping up, coming to the fore as being a really valuable, in the carbon markets. And that's because it's so easy to quantify and it's so solid. You make it, you put it in the ground and it's done. Unlike a lot of, carbon credits, which might be based on, planting trees or something, you got to monitor those trees. And I mean, that I'm not against it. It's a good thing to do, but it does mean there's a lot of cost to monitor the trees to make sure that they didn't die or get burned. Whereas this biochar, once it's in the ground, it's there, it's pretty safe. So this is the protocol, and the hope is that you've got a certain cost for doing a forestry project, a fuels reduction project. You have a certain amount of money for that. And it costs more to make the biochar. So could the carbon removal credits fill that gap? That's what we're hoping. And we're developing this app. It's a smartphone app, and it just lets you kind of record and verify what you've done so that you can be eligible for the credits. So it starts with looking at the feedstock, measuring the moisture, then verifying the kiln, how big it is, verifying the burn quality. So you always have the flame, so it wasn't putting out a lot of smoke. Then measuring, weighing the char and quenching it, and then verifying that it went in the ground. And it's really all just done with taking pictures with your smartphone. So this illustrates again the steps. You need to measure the feedstock moisture. You need to take different pictures or short video clips during the process to make sure it was clean and wasn't emitting a lot of smoke. Then at the end, we have people weighing a bucket of hot char. And the reason to do this is that once you add water to it, the weight changes. Because biochar will absorb like 6 times its weight in water. So to get dry weight, we have to measure it when it's hot and dry. Then we get the volume. So this gives us bulk density, and then we get the volume by measuring the level in the kiln. And then we can get the dry mass. And dry mass is the basis that you need to calculate carbon. So then after it's quenched, we call these bones, half charred pieces, you can take a picture of those, and that's all you have to do. That's all the crew has to do. And then we can verify that a certain amount of carbon was removed from the atmosphere. All right, so if you're interested especially in this biochar and forestry aspect of things, we have a Biochar in the Woods discussion group. It's an email list, and that's where I'll make announcements about our monthly Zoom meetups, the first Wednesday of the month. And so if that interests you, we'd love to have you join us. And I think I'm done talking now. So let's have some questions. Okay. I think I answered the one about the difference between regular charcoal and biochar. If adding biochar to compost increases the temperature of the pile, would you then need to do this process separate from vermicomposting to not cook the worms? Well, that's a really good question. I've used a lot of char in my worm bins, and the main thing about using char in a worm bin is that you want to make sure it's moist, because they don't like dry biochar. It's kind of abrasive. But I haven't had it, it's just really a matter of how much you add. So really adding biochar to compost is very interesting. It's very dependent on the carbon to nitrogen ratio. So in a worm bin, you need to have a lot of carbon anyway, or it will heat up. You don't want to add too much if you're putting food waste in your worm bin. If you add too much food waste at a time, it gets kind of nasty. So you usually have a lot of bedding, a lot of paper, and you add just little bits at a time. And so in that case, the biochar will actually help keep it cooler. And this is what I've noticed with biochar and compost. It's very sensitive to the amount. So the carbon to nitrogen ratio is what you need to have right to get thermophilic compost. And so if you add more than 5 or 10% biochar, it'll actually cool the pile. I've seen this happen. However, for me, that is not a problem because I don't really care about thermophilic compost that much. Why do you want hot compost? Mainly you want it to destroy pathogens. So in my compost, it's garden compost. I'm not worried about pathogens. No, there's not manure in it. And the other reason would be to destroy weed seeds, which, you know, I don't know, I just deal with it. But a cooler compost can still be a very good compost. So yeah, I don't know if that answered your question, but basically it's about the carbon to nitrogen ratio. And you only get hot compost if you have it in a pretty narrow zone, which is about 30 to 1 carbon to nitrogen. 25 to 1 actually. Okay, what's the difference between ash and biochar? So ash is just the mineral part. Ash is white. It's calcium carbonate, it's oxides, you know, iron oxide, magnesium oxide. Ash is minerals, doesn't include carbon. There's something called high carbon ash, but that is just a mixture of char and ash. And for forest management, is there a move toward mobile biochar plants? Well, you know, there have been a few different attempts. I showed you the air curtain burners and our kilns. There have been some attempts to make more complex mobile biochar plants. Like there was one that they demonstrated at Diamond Lake quite a few years ago that was going to make a bio oil. So you can condense the gas and make an oil. And they thought that would be a great answer. But the truth is that these industrial facilities are complex. They need electricity, for one thing. So if you take them out in the woods, you need a generator to generate electricity because there's nowhere to plug them in. They have a lot of moving parts. They break down. You're not in near town, you know, you're 50 miles from town. They're not very practical. And they've been tried and they're just not very practical. And you can make way more biochar in an air curtain burner or a kiln than you can in some of these. It makes more sense to take it to town if it's within a certain transportation distance. So the 55-gallon drum, I've used 55-gallon drums. Usually when we use those, we use them vertically, and we use them as an updraft gasifier. So we actually have holes in the bottom of the drum. They're really good for, you know, they won't hold a lot of branches, right? When you use a 55-gallon drum, you have to cut up your material, and that's a lot of work. You know, sometimes you might have stuff that's already the right size. Like I am able to get mill ends from a place that makes trusses, you know, for building. Or, you know, there's a furniture plant in Grants Pass where I can get their offcuts. And so those are little chunky things, and those work great in a 55-gallon gasifier. And there's lots of plans for those on the internet that you can find. So, yeah, so that can work. I've also seen people take a 55-gallon drum and cut it in half lengthwise to make a little trough. And you could also just use a water trough, a cattle water trough. You know, any container will work to make biochar pretty much. Okay, does the type of wood matter? Yeah, it does. Most types of wood we can deal with just fine, but they're going to be different. Like for instance, poplar. I was asked to come and do a demonstration at the water treatment plant in Springfield, Eugene, and they have a poplar plantation. And so I get there and I was told that it was dry and it really wasn't. And that's because if you take your moisture meter and you put it in the end of a log, it'll show one reading because wood dries from the ends. Whereas if you put it in the middle and, you know, in the side, it'll show a different rating. So they had just measured the end and found it was dry, but it was really like 50% moisture in the middle. So I was get there and I'm like, I don't know if I can burn this stuff, but we got it going. And what I found was once it was going, that poplar dries quickly in the heat because it's very dense. So it's a matter of density. Oak that was 50% moisture, I would not even try. It just wouldn't burn because it's a very dense wood. And then you have things like manzanita, which is dense, but it's small and it's got a lot of volatiles in it. And we could burn that green. So even though it might be, say, 50% moisture on the moisture meter, it's small and it has volatiles in it that haven't, you know, when you dry wood, you lose fuel value because a lot of the volatiles just dry and leave in the sunshine. So there's all kinds of different things like that about the type of wood. At the end of the day, though, when you have the char, it's not going to be very different. If you made it in a flame and it's nice and hot, most of the volatiles will be gone. And so, you know, the char itself will be pretty much char. It will be different in terms of density, though. So, you know, oak char is going to be heavier than fir char, just more dense. All right. Okay. Deborah was referring to manure vermicomposting, not worm bins per se. Yeah. Well, yes. If you don't want to kill your worms, don't add so much biochar or add a whole lot of biochar so it doesn't get hot. But, you know, this is something you've just got to try it for yourself, because to me, the beauty of biochar that we make ourselves, you know, on the farm or in our backyards for the garden is we're using what we have at hand. You know, we don't want to buy stuff. We don't want to buy inputs. We want to use what we have at hand. And everybody's got different stuff. You've got different soil. You know, your soil pH is different than mine. You've got different kinds of wood and brush. You've got different kinds of manure or, you know, other kinds of ingredients for your compost. So you need to do your own experiments. And it's not hard. You know, I did an experiment with chicken manure. I'm checking the time because I'm just going on and on here. I did an experiment with chicken manure where it was from an egg laying operation, no bedding, pure nitrogen, smelly, slimy stuff. Okay, so I made 3 piles. One was just a plain old manure. One was chicken manure with 25% charcoal, and one was half and half manure and charcoal. And the one with the most charcoal got the hottest. And that's because it's that carbon to nitrogen ratio. So you have something that's almost pure nitrogen. You add the right amount of carbon and it takes off. The other thing that was really interesting about that experiment is that the pH changes. So the manure was like 8.5 and the char was like 9. And you'd think when I mix them together, they'd be pretty alkaline. What happened really was when they composted, the pH dropped. So that was really interesting. Okay. So yes, for your manure, if you want to vermicompost it, do some experiments and figure out how much biochar you want to add. Maybe you don't want to add a whole lot if you don't want to cook your worms. Or maybe you want to add so much that it cools it. I don't know. Okay, how much biochar do you need to supercharge an acre? Again, you know, you don't want to think about adding it all at once usually, because it's a new thing you add to soil. Your microbes need to adjust. Everything needs to adjust to it. So it depends on what you're growing. If you're growing corn, you know, or something like that, just put it in the seed row, you know, band it like you would band a fertilizer, band it with a fertilizer. And you'll get you put it in the root zone of what you're growing. If you're growing an acre of cover crop, a legume cover crop, then, you know, you're going to, of course, broadcast it. You could mix it with the seed. So you make sure it's right there with the seed. How much do you need? With an acre, probably at least if you had 10 yards, that would probably be good for an acre with the legume cover crop. But any amount's going to help, So add a little bit of time as you get it. Add it in the root zone. What's the difference between a gasifier and a kiln? Good question. So a gasifier is the difference between updraft combustion and counterflow combustion. They're both basically a gasification process, because gasification is adding heat to the material, just enough to separate. You're doing it in the presence of air. But there are lots of different gasifier designs, so that's really actually a more complicated question. But the main difference between an updraft gasifier and a kiln is just the way the air flows. What about dead sage and rabbit brush and cheatgrass? Those things could be kind of difficult. I did get to try to char some rabbit brush. It was the middle of winter and it was pretty damp and it was pretty hard to burn. So dead sage probably would burn pretty well. Again, if it's dry, it could burn. Cheatgrass, any kind of grass or straw or anything like that that packs down is not going to do very well in a kiln, in a flame cap kiln. Juniper should be brilliant. Juniper should work really well. Yes, and I think this case study, I think they used my Oregon kiln for that one. And they were happy with it. How can you quantify the environmental benefit of a smokeless fire versus a conventional fire? Yeah, a lot less emissions. And we have some studies. There've been a few studies and we're about to do a whole bunch more. But basically, just think of the difference between a wet smoldering burn pile and a nice dry flaming burn pile. That's the main difference. And you've seen that, you've seen the difference. So it's particulates, smoke, and it's also methane, which is really important. It's really important from a greenhouse gas climate standpoint. Methane is, if you have a wet smoldering fire, you're going to get more methane, and that's probably more dangerous. It's worse for the climate even than the smoke. Okay, in the case of the farmer who applied biochar composted with his barn manure, was there any problem with the biochar remaining on the surface? And I'm not sure what you mean by that, Brian. Remaining on the surface of the barn, or I'm not sure what you mean. Maybe you could clarify that. On the field. Right, because they just spread it with the manure spreader. That's how he spreads his manure. So it was just his standard practice. It's just the manure had some biochar in it. I don't know if the biochar, I wouldn't think so. Like there's a guy in Australia who's been doing this for a while, actually feeding char to his cattle. They poop in the field and deposit the char with their manure right there in the field. And what he's seen is the dung beetles take it down. So the dung beetles come up and grab it and take the whole thing down into the soil. And so I'm not sure, if there's dung beetles on this particular farm, but there's probably something that's doing that. So good old dung beetles. All right. Well, I think that's the last of the questions here. People could feel free maybe to speak up too if you want to talk or share anything, because we've got 15 more minutes. Is that right, Pam?
I wonder if anybody is using biochar to some capacity on their property or for their business. I'm just curious if this is something that anybody has experience with already.
Anybody?
Well, I mean, so we've been doing a lot of stuff on the ranch. I'd love it if other people wanted to talk about it, but at Pine Meadow Ranch, we use biochar around trees to try to help reduce drought stress. We put it in our compost. We have some experiments going in our pastures with it. And we mix it in with we've just put straight biochar, just kind of spread around the forest floor to kind of replicate some of the nutrient cycling from fires. So yeah, we just kind of do all kinds of things with it. We're always out there playing with biochar.
It does have a lot of uses. In my barn, I have a little toilet system. There's no flush toilet in there. And so I have 2 buckets. One is a urinal. And boy, I'll tell you, you put some urine in biochar and put that on your compost. Or even just put it right in a garden bed. It's great stuff. Yeah. Somebody asked, can you make biochar in a wood stove? Yeah. Some people have stoves that they shut down at night and, just kind of leave a log in there smoldering with not much oxygen. You open that up in the morning, you see chunks of char. I have one friend who's made gobs of char that way. Every morning he just takes a shovel, scoops out the char chunks and, puts them out with water. You can also make a little retort. A retort's just a closed vessel. I made one out of some pipe. You can make one. There's somebody who sells something called a Biocharlie, which is a piece of stovepipe with ends. Anything, any kind of metal container. Make sure you poke a hole in it. A paint can works great. Go to the hardware store and get a clean paint can, a 1 gallon can. Poke a few holes in the lid with a nail and throw that in your wood stove. Yeah, you can't make a lot, but you can make some. Do you recommend adding some biochar to soil and planting seedlings in reforestation efforts? If so, then what's a good amount? Yeah, absolutely. The Redwood Forest Foundation people are doing that. What's a good amount? It's going to depend on the species and the soil, but be a little conservative. But if you're planting a fir seedling, a good handful with mixing it into the soil a little bit. When I planted fruit trees, I put in probably a gallon in a pretty big planting hole. So yeah, definitely anytime you're planting perennials of any kind, put biochar in the planting hole or biochar compost. Yeah. I'm curious how many folks here actually have livestock. There's a hand. Oh, Brian says it'd be great for asparagus because it loves high pH. That's good to know. I've never grown asparagus, but we're thinking about trying it. So it's good to know. Somebody posted a link to urine capturing. Yep. I mean, really, you think about, I started off the presentation with the information about, the humanure and returning the manure to the fields. And it was actually a big controversy in the 19th century when the cities were first developing their sewage systems. People got very heated about it. When you read those old journals, they were like, it's such a waste to send all that manure to the ocean, and then people got cholera because they didn't treat it. They just dumped it into the rivers and people got sick, and it was a big controversy. So sheep and goats, poultry, cows, horses, and chickens. So I have friends who've got horses, very fancy horses, and they started putting biochar in the barn, in the stalls, and they said no more hoof problems. No more, I guess there's a bacteria that gets in the hooves and they start delaminating, and they said nope, no more hoof problems. So that's worthwhile. The other thing is that animals just will eat it if you just leave it around. They will voluntarily eat it. Here's a story. Knew some friends who bought a ranch, it's outside of Ashland. They were new to it all, and they were really interested in biochar. Told them how to make biochar. They made a big pile of it, and then they called me and they said, yeah, we made this biochar and we left it there. We went back, a few months later, it was all gone. The cows ate it. They were so mad. I said, don't worry, that was a good thing, because they're going to be depositing it out in the pasture for you. So they will eat it. I've had deer eat it out of my yard, and when I left a pile, and chickens will definitely eat it. Pigs will love it. Pigs will really eat it. So I eat it. Actually make a tooth powder with charcoal. I'll bring you guys the recipe for that. It's great stuff. It's really good for dental health to use a little charcoal. Yeah. All right. People are sharing some nice links here. So I know when I record a Zoom, it records the chat as well. So you can save that with people to save all these links. And let's see. I can put in the link to the Biochar in the Woods.
Kelby, could you tell us a little bit, once you've gotten that link, can you tell us a little bit about what to expect on the 11th for the
Sure. Yeah.
and how to prepare?
Yeah. Well, I'm hoping that we have some dry wood. That's always my big hope. And we can go through a lot of wood, so I'm going to bring the big ring fire kiln, the new one, and it's 5.8 cubic meters in capacity, cubic yards. And so it can use like 10 times that volume in stuff. So we can, we can make a big full load, or we can just, if we get tired, we can just stop whenever we want. I think we're also going to try some conservation burns, some burn piles, and you guys will have some water there so we can put everything out. And so when you show up, be prepared to do a little work or not. If you don't want to, there'll probably be plenty of people who want to help. But wear some good boots. Wear fire resistant clothing. Like, don't wear your good down jacket. Wear something that's wool or cotton on the top. And if you have long hair, pull it back. And that's basically it. Bring some leather work gloves if you have them. But basically, you're just going to be picking up sticks and small logs and things and throwing them in the kiln. Bring some drinking water. Are we having muffins? Did I hear somebody say we're having muffins? I think, are we asking people to bring a lunch?
There will be coffee and some pastries from Sisters Bakery and Sisters Coffee, but you're more than welcome to also bring a lunch in addition to that.
Yeah, well, we'll be there, I think 9:30 to 3, is that what we said? Yeah, so you might want to bring something to snack on, bring some water, bring your camera, take some pictures, bring a bucket or bag or something so you can take some charcoal with you, take some biochar home. And bring your questions, as you think about this more, if you have more questions. Can we bring hot dogs? I don't know why not. Yeah, why not? Sure. I'll bring one of my small kilns too, one of the smaller pyramid kilns. That's really nice just for a warming fire. And is it been cold there? Do you think it's gonna be cold during the day? Like 15 degrees, 20 degrees? Not that cold?
Probably in the 40s.
Oh, in the 40s. Okay.
It's actually it's supposed to be 55. So we're going to have a beautiful day, it looks like. At least right now, that's what it's saying.
All right. Good. Well, good. It won't be like North Dakota where I had to make biochar in 15-degree weather. I couldn't believe it. Okay, simulated urine. Oh, wow. I guess if you want to buy something.
If you don't have livestock, you don't have animals.
I have animals. I have myself. I have my husband. We're animals.
Fair enough.
Yes, if you have people around, just put biochar urinals everywhere. And in fact, during the Slater fire, the 2020 Labor Day fires, we were evacuated for 3 weeks, and all of our neighborhood. And we went over to some friends in Ashland, but a lot of people had nowhere to go. So my friend Brenda, who has 400 acres in Grants Pass and kind of is set up for a camp, she had 30 people there for 2 weeks. And she called me and she said, I have one outhouse. It is not big enough for all these people. I can't get any porta potties. You just can't get them. What should I do? So, I said, you've got charcoal. We've been making charcoal. Get your biochar, get your buckets. You can do it. So and there's these things called a luggable loo. It's really nice. It's a bucket with a lid and a seat and everything. And it's just a good thing to happen. If the power goes out, and your toilet doesn't flush, to have some alternative, where you can treat your waste. And it's, so the manure, or excuse me, the urine and the charcoal is great. Urine is pretty sterile unless somebody's really ill. It's usually pretty sterile. It's pretty safe to just put it in your compost. The poop, which I treat separately, I add bokashi to that. Bokashi is it's a culture. It's a fermenting culture, and there's a institute in Germany called the Hamburg Technical University that has specialized in what they call terra preta sanitation. They've come up with these systems and done all the research looking at adding charcoal and the EM1 bokashi, which is like a silage inoculant, to human manure. And they've shown that it deals with the pathogens. So basically between the charcoal and the bokashi, all the pathogens are gone. And so the only thing that's possibly a concern that's left is certain type of worm eggs. And for that, you just, you take the stuff and I store it in a barrel for a couple of years. And that's all it takes, is just some time for those worm eggs to lose their viability. So store it in a metal barrel for a couple of years, and then I use it on trees, so I haven't gotten quite brave enough to put it in the food garden yet. But you can do sanitation. Biochar can really help with sanitation. So for any kind of emergency situation, it's a good thing to know about. You can also filter water with it. You can make a sand pre-filter and then use a biochar filter to filter water. Okay, time check. I guess we're about done. Okay, human urine does carry pathogens such as hepatitis. Thank you, public health professional. Thank you. Yes. Yeah. I'm talking to my family here. Everybody else's urine, I wouldn't just use willy-nilly. But if I'm, confident that my family is healthy, I'm not worried about it. And yeah, composting is definitely a better idea. Good point. Okay, anything else, guys?
We are at time.
Thanks for sticking with us.
Any questions that you have, there'll be plenty of time for asking those in a week and a couple of days. So make sure you write those down and have those in mind. So cool. Any last thoughts? Otherwise, I appreciate you guys for being here, and we'll see you pretty soon. All right.
Yeah, thank you, Kelpie. Thank you, everyone.
Okay, I'm looking forward to being there and meeting you all in person.
Great.
Bye.